Nowadays, manufacturers want to see a safer, more effective product that meets the consumer's requirement. Liquid egg, for example, can replace the traditional egg product as an industrial food product. One of the thermal method, which is pasteurization, is used in liquid egg to eliminate bacteria such as salmonella, but unfortunately this method will likely destroy the nutrient and protein structure inside of the egg. So as an alternative heating method, Ohmic heating is introduced to be used as it is faster with the same heat but protecting the liquid egg quality.
Next, I'll be explaining the principles of ohmic heating for liquid egg processing. Ohmic heating is the conversion of electrical energy into thermal energy. They are also known as chill heating. Unlike conventional heating, heat is generated directly within the liquid egg due to the electrical resistance that result to the heat is rapidly and uniformly. The process is based on Ohm's law and Joule's law. In the ohmic heating system, the liquid egg is placed between two stainless steel electrodes that are connected to alternating current power supply. The liquid egg acts as the conductive medium, allowing electric current to generate heat throughout the food product. Lastly, the efficiency of ohmic heating depends on the factors such as electrical conductivity, temperature, voltage gradient, moisture content, and ionic concentration.
Now let's look at the industrial application of ohmic heating, specifically for the pasteurization of liquid eggs. In commercial egg processing, manufacturers need to achieve rapid pasteurization that delivers a 5-log to 6-log reduction of Salmonella enteritidis, which is the main pathogen of concern in liquid egg products. The USDA requires a minimum treatment of 60 degrees Celsius for 3.5 minutes to hit the 5-log reduction, while in Europe, typically 2.5 to 6 minutes at slightly higher temperatures between 64 and 68 degrees Celsius. The traditional method used for this is called HTST, which is high temperature short time pasteurization. It works, but it comes with real drawbacks. Since HTST relies on heat transferring from a hot surface into the liquid, leading to uneven heating throughout the product. It also causes protein fouling where egg protein stick and burn onto the equipment surfaces, which reduces the efficiency and increases cleaning costs. And importantly, the protein themselves can degrade under this kind of surface heat, which damage the egg's functional properties like the egg's ability to form or gel, ultimately reducing the overall quality of the product. This is where ohmic heating offers a better alternative. Instead of relying on an external hot surface to transfer heat, ohmic heating generates heat directly inside the product itself through electrical resistance during processing and alternating current at a standard frequency of 50 Hz with a voltage gradient of around 20 volts per centimeter is applied directly to the liquid egg. Since the heat is generated internally and volumetrically, the temperature can rise very rapidly, taking the liquid egg from refrigerated temperatures of around 4 to 10 degrees Celsius all the way up to the pasteurization temperature of approximately 60 degrees Celsius in just 105 seconds. This rapid volumetric heating shortens the overall thermal residence time, helping to maintain its quality, destroying harmful microorganisms, and also eliminating cold spots that could result in underprocessing and potential food safety failures.
Now I will explain the advantages of using ohmic heating for liquid egg processing. The first advantage is rapid and uniform heating. In ohmic heating, heat is generated throughout the entire liquid egg as electricity passes through it. This allows the product to heat evenly, minimize temperature differences, and prevents localized overheating, which helps maintain the quality of the liquid egg. The second advantage is better retention of functional quality. Because ohmic heating uses shorter heating times than conventional pasteurization, it better preserves the functional properties of egg proteins, such as forming, emulsifying, and gelling abilities. This makes it more suitable for producing high-quality egg products. The third advantage is lower energy consumption. Ohmic heating converts electrical energy directly into heat inside the product, making the process more energy efficient. It also reduces processing time, which further lowers overall energy use. Finally, ohmic heating has the potential to improve shelf life. It can effectively destroy microorganisms while causing less damage to the quality of the liquid egg. As a result, liquid eggs processed by ohmic heating can achieve a shelf life of approximately 12 weeks, which is longer than many conventionally pasteurized liquid egg products. Next, I will discuss the limitations of ohmic heating for liquid egg processing. The first limitation is that it is dependent on electrical conductivity. The heating efficiency of ohmic heating depends on how well the liquid egg conducts electricity. Since electrical conductivity can vary depending on the egg's composition and temperature, the heating process may become less consistent if these factors are not carefully controlled. The second limitation is parameter sensitivity. The performance of ohmic heating is highly dependent on processing conditions such as the voltage gradient, temperature, and processing time. These parameters must be precisely controlled to ensure effective pasteurization while maintaining the quality of the liquid egg. Another limitation is the complex equipment required. Ohmic heating systems need specialized electrical components and monitoring equipment, making them more complex and expensive than conventional heating systems. This can increase both the initial investment and maintenance costs. Finally, electrochemical reactions may occur at the electrodes if the system is operated under inappropriate conditions. These reactions can damage the electrodes and may also affect the quality, color, or flavor of the liquid egg.
Today I'll be talking about the sustainability and best practices of ohmic heating and liquid egg processing. Sustainability is important because it helps to protect the environment while ensuring that resources remain available for future generations. First, it also lowers the need for cleansing chemicals and utilities during the cleaning in place process. Second, ohmic heating extends the shelf life of liquid eggs by effectively reducing microbial growth. Unlike traditional heating, it preserves the original properties of liquid eggs and minimizes food waste. Lastly, ohmic heating improves nutritional quality. It enhances protein digestibility, preserves vitamins and minerals, and provides safe, nutritious product for consumers. To ensure these sustainability benefits are achieved, several best practices should be followed. Food manufacturers should optimize the voltage and processing temperature to ensure uniform heating without affecting product quality. Regular maintenance and cleaning in place procedures should be carried out to maintain hygiene and equipment efficiency. Finally, monitoring energy consumption and integrating renewable energy sources such as solar power can improve the sustainability of the process.
Now, I will discuss the challenges and industry issues associated with ohmic heating for liquid egg processing. The first challenge is scale-up difficulties. While ohmic heating has shown excellent results in laboratory studies, it can be challenging to apply the same performance in large-scale industrial production. Manufacturers need to ensure that the liquid egg is heated uniformly throughout the entire process to maintain both product quality and food safety. The second challenge is the high capital investment. Ohmic heating requires specialized equipment, electrical systems, and control units, making the initial installation cost much higher than that of conventional pasteurization systems. This can discourage small and medium-sized companies from adopting the technology. Another challenge is maintenance requirements. The electrodes and other electrical components require regular inspection and replacement of the equipment if necessary. Proper maintenance is essential to ensure consistent performance, extend the equipment lifespan, and maintain food safety standards. Finally, there is the issue of regulatory approval and validation. Before ohmic heating can be widely adopted in the food industry, manufacturers must validate that the process consistently meets food safety and quality requirements. This often involves additional testing, documentation, and approval from regulatory authorities, which can be both time-consuming and costly.
In conclusion, ohmic heating is a promising alternative to conventional thermal pasteurization for liquid egg processing. Its volumetric heating enables rapid and uniform heating, ensuring effective microbial inhibition while preserving nutritional and functional properties. It improves processing efficiency through faster pasteurization, shorter processing time, and uniform heat distribution. It also supports sustainable food processing by reducing energy consumption and food waste. But however, further optimization of equipment design and operating parameters is needed for wider industrial applications.